This is the Chemistry 1, Chapter 1-2, Introductory Part 2, Handout 2, Commentary C. In this final commentary for the introduction handout, I'm going to talk about how to name organic compounds, and I started off talking about it in B, but I'll finish it up in Part C. So, in this slide on 25, the first step in naming, again, is to figure out what is the parent chain and what is the branch. Keep in mind they have alternate names. Parent chain's alternate name is main chain. The branch's alternate name is substituent. Say that 10 times. But branch is my favorite name as well as parent. So the example on the right, here we see the longest chain, that's the parent, and then any offshoots coming off of the parent, these are branches. Now we have to think two-dimensionally. So if I were to open up ISIS, I could see in this example that the parent may not always be on the x-axis. It could be on the y-axis. So you have to think two-dimensionally. So in this example, I'll go ahead and I'll lasso where the parent is. And it's pretty obvious, it's in red. The branch is what you can see right here. Now again, we call this the parent in red because this is the longest chain that's present in the hydrocarbon. Going back to the PowerPoint and moving to slide 26. These are the parent chains you absolutely need to memorize, along with their IUPAC name. Keep in mind, for carbons greater than 3, if it were in a circle or cyclic, then it would be called a cyclopropane. If they are straight chain, then we just call these alkanes. So make sure you know the difference. These are the starting branches, or branch names that we're going to be learning. There are two types of branches. The first one is alkyl groups. The second one is halogens. In order to name the branch, you turn the ane of the parent name, such as methane, to ul. So for example, if I turned methane into a branch, forming a methyl group, or an ethane into a branch, forming a ethyl group. For halogens, you change the halogen name ending in O. So fluorine becomes fluoro. Chlorine becomes chloro. So here's another slide showing the transition from ane to ul for alkyl groups. You'll be responsible for knowing all of these on future quizzes and exams. So let's put everything together. The first thing we do is figure out what is the longest parent chain, at which point we go ahead and figure out if this is the parent, then where is the branch. In this case, highlighting in blue, this is going to be the branch. We then need to go ahead and figure out on what carbon the branch is located. So think of it as a zip code. In this case, we go ahead and we label from the side closest to the branch. So in this case, this is the side closest to the branch, and we label each carbon along the parent. Let me say that again. We label each carbon along the parent, which is closest to the branch. So carbon 1, carbon 2, carbon 3, carbon 4. We then go ahead and put the branch as a prefix name in front and we put the parent name in back. Hence, it's 2-methyl-butane. In this example, when we have multiple branches of the same type, so for example, in this molecule right here, we have 2 branches and they're of the same type, then we go ahead and we use di, tri, and tetra. Di meaning there's 2 branches of the same type, tri there's 3 branches, 4 there's 4 branches of the same type. The rest of the rules apply as the same. So the first thing we do is we figure out what side is closest to the nearest branch, and then we go ahead and label it. From there, we do something a little bit different. We need to put the address of each one of these individual branches. And we put the notation of a comma. So for example, if they're both located on carbon 2, then it's 2, 2. Notice on this example over here, so the molecule to the right, and I'm circling the branches on the molecule to the right, one is on 2, one is on 3. So therefore, it's going to be 2, 3. Afterwards, we need to tell people how many there are. In this case, 2, 3 dimethyl. And then the rest of the name, butane. Please be careful. You have to think two-dimensionally, figuring out what is the parent. Again, it's the longest chain, and it doesn't have to go left to right. It can go in all different directions. So in this case, I'm circling the parent. And to use my colors, I'll go ahead and I'll circle the branches, and I'll use the branches in green this time. So in this case, the branches are 3,3-dimethyl, and then the parent is going to be butane. I'm sorry, the parent is going to be pentane. Have to be careful. So in this case, the parent is going to be pentane. So 3,3-dimethyl pentane. Let's go ahead and take a look at the one over here. And let me go ahead and erase all these marks. I'm going to go ahead and circle the parent, and then the branches are here. Keep in mind, this is the side closest to the nearest branch, so 1, 2, 3, 4, and my ugly 5. So in this case, it's going to be 2,3-dimethyl, and then the parent name is going to be pentane. In this example right here, we are looking at substituents of different types. So in this case right here, we have 2-bromo, 3-methyl pentane. So what I'm doing is I am stacking the prefix branch names right up in front. So I'm going to go ahead and highlight in blue just out of habit. So here is my branch. Here is my branch. The side closest to the nearest substituent is right to bottom. So in this case, 1, 2, 3. So in this case, it's going to be 2-bromo, 3-methyl pentane. Keep in mind that when we are organizing these branch prefixes, we need to obey the alphabetical rule. So we're looking in front. B is lower in the alphabet than M, so it goes in front. We do ignore the di, tri as far as the alphabet arrangement goes. So we only look at the actual names. We ignore di and tri. Looking on the example on the right, I'm going to go ahead and label the branches. And this time I'll go ahead and I'll circle where the parent is. That's the longest continuous chain of that hydrocarbon. We then go ahead and organize it. In this case, 3-bromo goes up in front. If you can't see it, I'll go ahead and I'll label it for you. In this case, it's going to be 1, 2, 3, 4, 5. And then we have 2 methyls. Notice they're the same. Let me go ahead and clear the ink out of the way. Notice how they're the same branch type. So let me go ahead and label the same branches. They're the same branch type. So oftentimes we'll have a combination of branch prefixes. Some will be different, some will be the same. Also notice that when we organize our branches, they're going to be, again, organized alphabetically. And again, we ignore the di and tri in the alphabet rule. It's only the other branch prefix. Now going over to ISIS, let's go ahead and see an example. So in this example right here, we have a combination of same and different substituted, same or different branches on a parent. So in this case, for example, we have 2 fluorines, so it'd be a difluoro. We have 3 methyls, and I'm putting my hand over the methyl groups. Here's one, here's another, and here's another. Notice in this example right here, you want to go ahead and choose the side which it's too complicated. Okay. Let's go ahead and see an example. In this hydrocarbon right here, or hydrocarbon derivative, we have we have a fluorine and a fluorine. These are the same type, so they would be di. Here we have a methyl, methyl, and methyl. So then we'd have a trimethyl. And then following my cursor, here we have the parent chain. And we'll be starting from left to right as it's closest to this parent N, or this parent N is closest to this substituent. So let's go ahead and name it. And we have a 3,4 difluoro 3,5,5 trimethyl nonane. Let's go ahead and see an example. In this hydrocarbon right here, or hydrocarbon derivative, we have a parent chain which is in red. Notice how it's two-dimensional. So don't assume that if it goes up and down it's a branch. You have to count the longest chain in order to determine the parent. We have 3 different substituent types. We have a propyl, we have a dimethyl, and we have a chloro. So let me go ahead and auto-name it. And here we have a 4,5,6 trimethyl 6-propyldecane. Whoops. This one should have been a fluorine. Let me go ahead and change that back. Alright, so let me go ahead and rename it again. There we go. So we have a 5-fluoro, 4,6-dimethyl, 6-propyl decane. Let me go ahead and clean that up really quick. Now, what happens if there is a tie when you're trying to figure out what side to start numbering? If there's ever a tie, such as this example right here that I've just highlighted, then as far as this class goes, you're going to count from the side that is lowest in alphabet. So in this case, chlorine is lower in alphabet than fluorine. Now, as we get into more functional groups later on, and I'll explain those rules later, when we get into more different types of atoms, the rules become a little bit more murky, as organic chemists basically decided which ones they considered higher priority than others when naming. But for right now, we'll use the alphabet rule. So in this case, chlorine is lower in alphabet than fluorine when it's a tie. So therefore, this would be 1-chloro, 3-fluoropropane. Going back to our slides, we also have what we call common name IUPAC branches. So in this case, these are more complex alkyl branches. They're branches off of branches, if you will. And the IUPAC community, the scientists decided to go ahead and use their original common names, and they incorporated them into the IUPAC naming schemes. So in this case, you will have to memorize all of these that are circled. By the way, the ones that are not circled, these you should know automatically. But these are the common branch names that you will have to know. Isopropyl, sec-butyl, isobutyl, and T-butyl. Iso means middle, so that's where they get the name isopropyl. There are 3 carbons, and it's connected on the middle carbon, hence isopropyl. Sec-butyl, this actually refers to the fact that this carbon is connected to 2 other carbons. So we call this a secondary carbon, hence sec-butyl, as it's made up of 4 carbons total. This one is called isobutyl. And finally, we have T-butyl. T-butyl is my favorite. T stands for tertiary, also known as tert-butyl. So 3 different ways of saying this particular complex alkyl branch. Notice it's also T-shaped. T is a good name. So you will be responsible for knowing these. Going back to the ISIS examples, here's a nice one right here. Again, we're going to start from the side which is closest to the end. Here we have a tie. So in this case, we'll start from the side which either is more substituted. So in this case, this carbon that my hand is over, my virtual hand, this is more substituted. Or the side where the branch is lower in alphabet. This is also lower in alphabet for each of these. We're going to start counting from right to left. So here we have a T-butyl, which I will lasso. Here we have a isobutyl. Here we have a isopropyl. And here we have a sec-butyl. So you'll be responsible for knowing these. One unique thing about these special alkyl branches is that we consider the sec, the tert, and iso as all part of the common name. Consequently, you look at the S, the T, and the B. I'm sorry, the S, the T, and the I as far as the lowest in alphabet. I do want to point out that the AutoNav program isn't foolproof, so here it has trouble alphabetizing. So if I were to sit there and adjust this properly, then the isopropyl in this case is going to go ahead and go right up in front. I have to really take a look at ones that you should practice with, although this last one's probably way too big, and I wouldn't give you something like this on a exam, unless it's a bonus question. I do apologize if you're seeing all this miscellaneous click here and line here. It's a new piece of software and I'm still working out the bugs, so I apologize if those little unnecessary click comments get in the way. Now, finishing up our slides, let's go ahead and go back to the PowerPoint, slide 34, and let's finish this up. If you're dealing with cyclic alkanes, where the carbons are connected forming a cyclic structure, I don't want to use the word circle if I can't help it, because some of them are triangle shaped, as this one right here. Other ones are square shaped. And realistically, the shapes are more three-dimensional as they tend to twist and tort. But I'll use the term cyclic. If they're cyclic, you go ahead and you name it with the number of carbons with the word cyclo in front. So I'm underlining cyclo in front. If there's 3 carbons in the cyclic structure, then it's cyclopropane. I'm sorry, let me say that again. If it's 3 carbons in the cyclic structure, then it's cyclopropane. If it's 4 carbons in the cyclic structure, then it's cyclobutane. Adding in substituents is fairly easy, at least for this class. If there's only 1, then the starting location is going to be automatically carbon 1. So if it's a halogen, for example, 1-bromo-cyclopropane. If you have multiple substituents, to make it easy for this course, go by the alphabet method. There are what we call IUPAC priority rules, but that's more complicated. So most of my questions all of my questions on the future quizzes and exams will employ the alphabet rule. So in this case, B is lower in alphabet than E for ethyl, so therefore 1-bromo, 2-ethyl cyclobutane. In later chapters, we'll explore precedents, but for this first part, chapter 1 and 2, and the subsequent tests on these, go by the alphabet rule. Here's another example. In this case, E for ethyl, M for methyl, so 1-ethyl, 3-methyl cyclopropane. You want to start counting carbons in the shortest distance from one substituent to the other. So notice we go 1, 2, 3, and not the other way around, because that would be a longer distance. In this case right here, we have cycloalkane, and in this case, cycloalkane. Notice the molecular formula is the same, so these are just examples of cycloalkane structural isomers. Not a really new concept to learn. We've already learned about structural isomers, just more examples. Let's move on. You absolutely need to know these physical properties, so this is the memorization